now inviting Professor Miguel Rodriguez, who is a professor of IT technology at Huelva University. He studies intelligence systems and data mining, and he is one of the members of the KILL group. He is mainly interested in evolutive algorithms and its application in data mining and robotics. So he's very much in line with the learning of intelligent systems and robotics. Miguel Ángel, you now have the floor. Cuanto más lejos, mejor para mí. Mucha pantalla, mucha tecnología. Okay, so robotics and learning. Miguel Ángel? Thank you very much for this kind of introduction. I'm about to present to you a robot who does something else. And a motivation. Would like to do something in a different way. So I'm going to explain what led us to explain as to why we came up with these robots. It is because we thought that people who have a disability that makes it difficult for them to learn to walk again because of a lesion need to learn to walk again. It is something which happens in the unconscious level. It's not something that you can learn consciously. You learn it at an early stage, and if not, you have to relearn. And we look around at what exists on the market. A few years there was a platform called Locomat, where there is a forced movement in the joints where the users can make a small effort, and then there's a continuous measurement of the progress of the patient. So this Locomat platform was very useful, not only because it approaches the problem in a different way, but also because the user has a special motivation and has a special relation with the team and of professionals and the technology. And we have also observed that the rehabilitation works much better than with other methodological methods. So what is it that the platform lacks? Well, it doesn't have a learning process by the individuals, and experts changes the parameters based on medical criteria, and the control of balance is not included, so that part of the of your walking skills include controlling your balance. It's not sufficient to have to be strong enough. You need to be aware of your body and know your body, and I think that is the area where we can contribute ideas. And I think that platforms such as this are perhaps going in the right direction. So we began by showing that this methodology was very valuable and take steps to improve it. So we started by trying to learn about smoothness in your steps. The problem with robot walking is that it's based on sensors and engines which receive orders from a computer system, and we want to make sure that the orders are soft, and because as the body moves, the body tends to fall on one side. However, the human body walks in a dance-like manner so that we walk smoothly. So the most important parameter that we needed to change is that of lateral balance. One of the ways of ensuring this balance is making sure that your legs are properly separated. So we would include that in robot, but this balancing, this rocking was going to happen abruptly. So the idea was repeating the same process as human learning. A child, when he starts walking, normally takes very short steps and hangs on to furniture and then eventually falls. And he learns what movements work, which don't, and then he repeats the good ones. But he does not repeat that consciously. He mixes different movements so that he can ensure his balance at any point. For a child, it is more difficult to be in balance not walking than walking. So we thought it was a good starting point. Okay, so let me begin by explaining the complexity of the system. What do we mean by intelligent systems? This is based on a number of algorithms. And finally, what experimental studies have we conducted to prove that this methodology does improve on the original step? So the system is biped robots, which receives an order from a separate wireless platform. And these orders, these instructions, are followed by others to complete the step. So the robot measures parameters to measure the step at many points. The human body has many more senses than this robot. We have our eyes, our sense of balance, the sensation from in our feet, and the optimization algorithms work better with few parameters than with many parameters. The most important one is the softness, but then what's important is to teach the robot to walk on. If not, he would just stand up, put. So the part on intelligence, artificial intelligence, is an algorithm able of testing different combinations until the right step is achieved. This is an algorithm based on Darwin's evolution theory, and we also have this evolution-based algorithm. So we test different combinations, and as generations go by, as an individual has managed to improve his gait. This is the general description of the system so that you know what we're about to see. We have two separate platforms: the robot, who receives the information through a transmitter. Then he sends it to the computer system. The computing system then decides on the next movement, which is not a step, just a fraction of a step. Then